Today we are solving ISS 2021 paper 2 question number 16. So let us examine next question. We are random sample from normal population with mean 0 and variance sigma square. Then the confidence interval, central confidence interval for sigma square, that is the confidence interval with equal tail probabilities with the confidence coefficient 0.95 for large sample is given by. Okay, so we have given the following option. So we will not use here the distribution of chi-square because the options are not in the terms of the chi-square, so we will use this formula. Okay, so for large n, dy by dy by theta log L, where L is the likelihood, divided by variance of dy by dy by theta log L is following normal distribution. For large n, this quantity follow a normal distribution, so we will use this quantity to obtain the confidence interval for the sigma square. And also remember, this variance can also be written as variance of this can also be written as expectation of minus dy by theta square log L. Okay, and our theta is the parameter. Okay, so here our theta is sigma square, which is unknown. So let's write the likelihood first. So log L will be 1 upon 2 pi sigma square to the power n power minus half summation xi square divided by sigma square. Now log L will be now this should be in square root. Now minus n by 2 log 2 pi sigma square minus half summation xi square by sigma square. Now dy by theta log L. So theta is our sigma square, so dy by sigma square is equal to minus n by 2 2 pi sigma square into 2 pi minus half. This is equal to this, and also there will be plus here. Now dy by sigma square log L is now 2 pi will cut it out, and we are left with summation xi square divided by 2 sigma square whole square minus n by 2 sigma square. Okay, so we will be needing for here for substituting, so put at question number 1. Now again differentiate with sigma square, so we will be having summation xi square 2. Now the differentiation of ddx of this is nothing but minus 2 by x cube, so using this we are having minus 2 by sigma square cube. Okay, now similarly here n by 2 1 by x, differentiation of 1 by x is minus 1 by x square, so minus this will replace here and sigma square whole square. Now variance of this is nothing but expectation of minus of this, so let's multiply with minus here, minus minus minus, so there is also minus here, so this will be plus, and take the expectation both side. So this will be variance of dy by dy sigma square whole square log L. Now so this is positive and this is in negative. Okay, so if we take the expectation here, so in the denominator we are having sigma square cube, and in the above we are having I from 1 to n expectation of xi square, here n by 2 sigma square whole square. Now since xi is normal 0 sigma square, okay, and variance of xi is means sigma square, since expectation of xi is basically 0, so this is equal to expectation of xi square. Okay, so let's put sigma square here, so we are having n sigma square 2 sigma square cube minus n by 2 sigma square square, so sigma square will cut it out, here is square. Now n by, now I'm having, now 2 will cut it out here. Okay, there should not be 2 here. Now now 1 minus half is equal to half, so we will having sigma square whole square. So this is the variance. So now let's put equation 1 and equation 2 values in this. So the statistic is, now this is nothing but this summation xi square divided by 2 sigma square whole square minus n by 2 sigma square divided by, now variance of this is nothing but square root of this. So square root of this will be n by 2 square root of, now when we take the square root of this, so we will have 1 by sigma square here. Now, so in question it is written that the central confidence interval, that is a confidence interval with equal tail with probabilities. Okay, so suppose normal distribution is like this, so there is equal tail, okay, and the confidence coefficient is 95. Okay, so this is 95%. So for 95%, the value for confidence coefficient is given by 1.96. so it should be 1.96. 1.96 is equal to 95%. Okay, now we just need to solve this for sigma square here, and we will be getting the confidence interval for sigma square. So now we can common sigma square here, so summation x squared divided by 2 sigma square minus n by 2. So when we common 1 by sigma square here, so that will cut it with this. Okay, so we are having left with here only square root of n by 2. Now we can multiply here, okay, the whole expression. So we will be having 1.96 n by 2 minus 1.96 n by 2. Now let's consider only the left hand side expression. So now we can multiply with whole with this inequality with 2 by n. Okay, so here we will be getting 1. So let's multiply with 2 by n, then we will be having minus 1.96. so if we multiply under root n by 2 by n, so we will having under root 2 by n. So this will just reverse, and here will be summation x square 2 sigma square, and here will be n 2. Now 2 will cut it out, and this here will be 1. Now 1.96, this will be reversed. Now so let's add 1 here, 1. Okay, so 1 will cut it out. Now let's divide this inequality by summation x square by n. So 1.1 minus 1.96 2 by n summation x square by n. This will be 1 by sigma square here, and 1.96 1 plus 2 by root n summation x square by n. Okay, so now let's reverse this. So when we reverse this, so this will be reversed, and this will be our lower limit. Okay, reverse this, and this will be our lower limit, and lower limit will be upper limit with reversed. So let's reverse this. So summation x square by n divided by 1 plus now 2 by n or 1.96. Now similarly this will be summation x square by n. Now reverse this, 1 minus 1 2 by n 1.96 0.95. so these are the our lower and upper limit of the confidence interval. So let's check out the options. So in the denominator, so let's check out the options first. So option A is correct, because summation x square by n, and here is summation x square by n, and here is 1 plus square root of 2 by n 1.96, 1 plus square root of 2 by n 1.96, and here is negative. So option A is correct.